right, well, I definitely want to make sure we respect everybody's time, so I appreciate all of you guys for joining us. My name is Kelsey Noyes, and I'm a sales engineer with Neometrics. And like I said, thanks again for joining us. We're happy to spend some time with you. We're going to review how to choose materials for your 3D printing projects today. Great, and then so here's our agenda. So I'd like to start by telling you a little bit about Neometrics. Then we'll review a variety of 3D printing applications, and we'll discuss things you should consider for your specific printing applications. Then we'll look at some various materials available, including thermoplastics, composite thermoplastics, composites with continuous reinforcement fibers, and also metals. Then I'll share some interesting success stories with you. And then finally, we'll wrap up with a brief summary of 3D printing solutions. It should take about 30 minutes. I hope that's good with everyone. All right. Well, Neometrics has been delivering 3D engineering solutions since 2003. We provide scanning services for reverse engineering projects and also quality control inspections. We also have quite a few 3D printers in-house, so we're available to print parts for customers. We also sell equipment for 3D scanning and 3D printing solutions, as well as any related software packages. We provide complete training on all hardware and software solutions. And today's webinar will focus on 3D printing materials for Big Rep, Intamsys, and Markforged. But first, I would like to officially invite you to our open house that we're having next month. Come visit us Thursday, September 23rd from 10 a.m. to 4 p.m. Come see our 3D printing and scanning solutions in person. Feel free to ask us any questions about projects you're working on. Bring CAD files or parts to review with us. I'll go ahead and post a registration link in the chat, so be sure to click on it and register. We hope to see you in person next month. And now back to our previously scheduled topic. 3D printing is used in many industries with a wide range of applications, all requiring different material properties. In the early days of 3D printing, the primary application was basic, simple prototypes. But today we have the ability to use more advanced materials, so the applications have also grown considerably. Some examples are end-use parts. We have the strength and durability allowed for functional, complex parts at reduced costs. Tooling development. We can quickly print complex geometries that cannot or not easily be machined. Service or maintenance, we can create custom tooling or fixtures that will ultimately reduce downtime, which saves us money. And we have the ability to make functional prototypes for testing. So now you have the ability to evaluate actual part properties. You can make design changes, quickly print new iterations. What this does is it takes the guesswork out of engineering. You don't have to rely on just the simple, basic prototypes anymore. What are some of your applications for your current 3D printing projects? Feel free to drop us a note in the chat or let us know what industry you're from. There are many things to consider when trying to select a material for 3D printing. What is the primary function of the part? Is it a prototype? Will it be put to any tests? Is it going to be an end-use part that needs to be strong but also visually appealing? What are the specific requirements for the part? Does it need to withstand heat or flames? Is it a load-bearing part? Will it need to have any flex? Perhaps you need to prioritize these requirements. Which ones are the must-haves? How high of a priority is cost? And I realize this opinion might vary, even between people working on the same project. But it's always worth considering. How many parts do you intend on printing? Is this an annual number? Is there a cheaper alternative material that will still give you the expected quality? And finally, what about the color or finish of the part? Is this critical? If you find a material that meets all other criteria except for the color, perhaps it can be painted or dyed in a post-processing step. Thermoplastics are a very popular choice for 3D printing. We'll review commonly used materials such as ABS, PLA, nylon, and some high-performing materials from the PAKE family. There's a wide range of applications, as you see in some of these photos even, from medical braces to automotive applications and everything in between. ABS is one of the most commonly used and most versatile materials available in 3D printing today. It's really a great choice because it has structural integrity and detail. It's ideal for wear and tear parts. ASA is actually similar to ABS with a couple of advantages. It's actually stronger and stiffer than ABS. It also has excellent weather resistance, UV, water, thermal resistance. ABS can actually withstand the really hot temperatures of sitting in parked cars in the southern heat. It's a very popular choice for vendors attending trade shows that have sample parts they want to display, but they might be subjected to a lot of time in a hot car. PLA is also a very popular choice, and it's actually really easy to use. It's stronger and stiffer than ABS. It has great geometric stability. It keeps its shape when it cools. It's fully biodegradable, and that's great for the environment. PLX is derived from PLA, so it has all the same great qualities, but it's able to be printed 80% faster. So this makes it an excellent choice for large format parts requiring PLA properties. As shown in the photo, PLX was actually used to print the front and rear bumpers of this fully 3D printed electric car. The other two examples of parts are printed in PLA, the skull and the stool. Skulls are just fun to print. We actually have a few of them around the office here in different sizes and colors. The stool has a pretty complex geometry with all those intersecting lines. Fun fact, it can actually handle 1,000 pounds of vertical force before buckling. ProHD, this is actually very easy to print, and it's what we typically use here at Neometrics for our large printed parts. It's a PLA alternative. It has a higher temperature resistance, so it has minimal warping and shrinkage compared to a standard PLA. It also has similar characteristics to ABS, temperature resistance, tensile strength, and flex. It's fully biodegradable under the correct conditions, so it's definitely a green technology. And another advantage is it's completely food safe. It's approved by the FDA. The photo shows an example of a large printed part without any warping effects. You can also see it has a nice matte surface finish. Next, I'm going to share a video that demonstrates the heat resistance of ProHD compared to a standard PLA. So they just poured boiling water, and you see ProHD is on the left, and then the yellow strip is PLA. And so they're going to sit there, and you can actually see the PLA is already deforming. So the white one, the ProHD held up really great in the boiling water. Nylon has become a go-to in traditional manufacturing. So it's really not surprising it's also a popular choice for 3D printing. It's lightweight, flexible, durable. It's great for wear and tear parts like functional interlocking gears. But you do need to be careful when using this filament. You want to keep it very dry because it likes to absorb moisture. But this actually helps with post-processing steps like dyeing or painting. Do any of these materials look familiar to you guys so far? Do you have experience? Feel free to let us know in the chat if you're already using some of these. I Next, we're going to move on to PEEK, which is a great example of a high-performance thermoplastic. It has a very high strength and wear resistance. After annealing or heat treatment, it can be used in applications up to 500 degrees Fahrenheit. So this makes it ideal for many industries requiring flame-resistant material, such as aerospace. It is a challenging material to print, though, because it requires very high heat for its crystalline structure. It's also considerably more expensive than the previous thermoplastics we've discussed. PEEK has similar properties to PEEK, but it's much easier to print because it has a slower crystallization. It can also be used in applications up to 500F after annealing. So it's a great choice because it is easier to print, but it does cost more than PEEK. And now we're on to the next section of materials, composites. So we hear a lot about composites these days and how great they are, but what exactly are they? Well, the simplified definition is a composite is made up of two or more materials. So typically you'll have a matrix and a reinforcement. Composites offer a lot of benefits, such as strength, lightweight, corrosion resistance, design flexibility, and durability. Carbon fiber is a very popular choice because it's strong and it's extremely lightweight. So you've seen this in many everyday products like golf clubs, fishing rods, and bicycles. Carbon fiber helps to optimize the performance of race cars and even airplanes. Onyx is a great example of a composite material. To best describe this material, it's actually helpful to use an analogy of another very common composite we see every day. Concrete is made up of cement, sand, and aggregate. And actually, each individual component won't even hold its own shape with any amount of force, but when you combine them, they make a rigid, solid material. Onyx is created by combining a nylon thermoplastic with chopped carbon fibers. Well, we already know carbon fiber has very strong attributes. Another benefit of this blend is it also has a really impressive high-quality surface finish. A couple of variants of Onyx are also available. This one is Onyx FR, or flame retardant. You have all the benefits of Onyx: strength, a great surface finish, and it can now survive in a flammable environment. So it's a great choice for industries like automotive, aerospace, and defense. This video does a great job of showing how great this material is. Even under a flame, the fire is not spreading. It's actually just self-extinguishing. Another area of concern might be electrostatic discharge, which can be harmful to electronics. Well, you can use Onyx ESD to make sure that your parts remain safe. It's great for parts that might even cause any processing difficulty when charge builds up. So now electronics manufacturers can enjoy the benefits of 3D printing because they can create strong, high-quality parts, but they can still meet those strict ESD safe requirements. All right, and here are some other composite examples. So materials mixed with various chopped fibers. You'll see PEEK with carbon fiber. Here's an example of PEEK with glass fiber, a high temperature with carbon fiber, and then at the bottom there's a couple examples of nylon with carbon fiber. If you haven't already, you may want to try printing with a composite material. If strength and stiffness are high priorities, you may want to utilize continuous fiber reinforcement to optimize your parts. Looking again at the concrete example, how do we make concrete even stronger? Adding rebar increases the strength and stiffness. Similarly, we can add layers of continuous reinforcement fibers into the matrix or base of our material of our printed part. So now we're going to go ahead and review some of our filament choices available for CFR. This is a quick look at the strength of the various filaments available. We'll be looking at each of them individually in just a second, but it's not surprising that we see carbon fiber right up at the top. But it's also interesting to see how all of these fibers are stronger than the base materials alone, and you'll find those at the bottom of the chart. The first filament we'll look at is carbon fiber. The best combination for strength and stiffness is pairing Onyx with continuous carbon fiber reinforcement. This combination creates parts that are stronger than aluminum. So you have a great benefit. You can now make end-use parts and functional prototypes. You can easily print them in a fraction of the time it would actually take to machine those same parts. So now we're going to look at an Intron challenge. So this is a part with Onyx and carbon reinforcement. They're applying a lot of force to see if they can pull it apart. And it's showing you it's over 21,000 pounds right now, and it's still holding together. I just love it. So how far is it going to go? 22, oh, it just broke. So just over 22,000 pounds. That's pretty impressive. Kevlar is a great option if you need a forgiving and durable material. Kevlar is commonly used in bulletproof vests because the goal is to absorb a force and not break at high impact. Using nylon as a base and Kevlar as reinforcement results in flexible yet very strong parts. Fiberglass is a great beginner reinforcement fiber because it is high performing while still remaining inexpensive. This video does a great job of showing the strength of the part being reinforced with fiberglass compared to Onyx without any reinforcement, and then the other two materials that can't even hold the weight. So I think they does a nice job of showing how strong that fiberglass is. And finally, this is high strength, high temperature fiberglass. So this reinforcement fiber comes in second in strength, just behind carbon fiber. It's strong in both low and high temperatures. It's ideally used in high temperature environments like autoclaves and molds. A great combination would be using Onyx flame retardant with this high strength, high temperature fiberglass for a welding fixture, for example. All right, and now metals. Do any of you guys currently print with metal? What kind of technology are you using? Are there any materials you're currently using? Again, feel free to send me a chat. All right, we're going to cover a few of the metal options we have. So stainless steel is actually a very popular choice because it can be used for a wide range of applications. It's a strong, hard metal that resists corrosion. It can be heat treated as well and to increase the hardness if that's required. That will bring it to 95% wrought steel strength, which you can see in that chart. Copper is a great material, and that can be used where any thermal or electrical conductivity is required. Some companies have worked with aluminum over copper because the traditional processing challenges. And now those same companies can take advantage of easily printing parts with they can easily 3D print parts with copper. And so they can now benefit from this material's higher thermal and electrical conductivity. The chart illustrates common metals conductivity, and it's clear that copper is the best option. All right, Inconel 625. It's a unique superalloy that's extremely corrosion resistant and strong at very high temperatures. So it's a great for functional prototypes or end-use parts that are designed for harsh environments. All right, so now we'd like to share some success stories. So this is the first one we have up. JC Steel is actually a 100-year-old foundry and pattern shop, and they're located in North Carolina. They create patterns for sand casting. They use traditional materials like hardwood and aluminum. The molds are then used to create a large durable parts like iron to use in extrusion equipment. They are now 3D printing the mold patterns using ProHD because it has great strength for sand casting applications, and it's also environmentally friendly. They were able to reduce their expenses by 75% while also increasing their annual production by 50%. Now, the CubeSat is a standard cube module, and that's used for simple space observation and atmospheric measurement. The QB50 program uses 50 cube satellite network to complete a scientific mission to detect low temperature atmospheric layers. And the ideal material in this case was PEEK and PEEK carbon fiber. They were a great choice because for space, they have actually excellent radiation resistance. They work well in high and low temperature, and they have extremely low vacuum outgassing performance. All right, then we have a company in Italy. They use a lifting tool to move heavy engine parts like pistons around their factory and cargo ships. Their previous lifting tool was machined out of steel, but they actually found this was too expensive, too time intensive, and it was really just too heavy for people to transport. So they decided to redesign the part. They chose to use Onyx with carbon fiber reinforcement, and they were really happy with the results. The weight was then reduced by 75%. They were able to save $120,000 in just 8 months. And the tested lifting capacity was 1 ton without any deformation. But because there was a required safety factor of 4, the certified lifting capacity was 529 pounds. All right, and then we have PTZ. So they use a tool cooler to engage and disengage a cutting tool in the shank of an end mill through thermal expansion and contraction. So the more conductive the cooler, the faster they were able to reconfigure the tool. The original tool cooler was made with machined aluminum, which was simple to produce, but it took a long time to heat and cool, and it created a much longer cycle time than they were actually desiring. So 3D printing copper was the perfect solution to this problem. So this new design, it actually featured conformal cooling channels, which makes the tool cooler extremely efficient. This design is actually impossible to manufacture using traditional methods. The new copper design is 38% faster at cooling than the previous designs. They saved 111 hours per year by eliminating about 40 tool changes per year. And so that means a savings of $7,000 a year in just machine time alone. All right. Well, there are a lot of things to consider when choosing materials for 3D printing. So I've shared some information of some options that are available. I encourage you to reach out to us to discuss any of your specific applications, and we'll be happy to recommend the ideal printing solution. And to wrap up, I just wanted to review some of the solutions that we have available currently. So here are a list of materials offered for big rep, large format 3D printers. We reviewed a handful of these during the thermoplastic sections. They're considered open printers, so you do have the option to use other material as well. The Big Rep Pro and the Big Rep 1 both have really large printing volumes, about 1 meter cubed, so they're perfect for large parts. And the Studio G2 in the middle has a print volume of 1 meter by 0.5 meter by 0.5 meter. These are materials offered by Intamsys. the pyramid shows how they can be categorized. You have your biodegradable thermoplastics, your general thermoplastics, engineering thermoplastics, and then finally, high performance materials. The FunMat HT is an entry-level 3D printer with a volume of 10 inches cubed. There's also the FunMat Pro 410, and that has a print volume of 12 by 12 by 16 inches. And then the FunMat Pro 610 HT has a large print volume of 24 by 20 by 20 inches. And I'm happy to share more information about any of these printers and materials. Just make sure you reach out. These are the Markforged composite printers. There's the desktop series and the industrial series, and they all print the composite material Onyx, and some of them have options to also print the continuous reinforcement fibers for additional strength and stiffness. We also provide printing services as well, so if you have any projects, definitely send us your CAD files. And then finally, the Markforged Metal X printing system. It actually consists of 3 components. So you have the printer, the wash station, and the center oven. It's an office-safe 3D metal printer. There's a nice selection of metal materials. So we've covered a few of them, but there's also some tool steels available as well. All right, well, I want to thank you all for joining us today. I hope you found that this webinar was helpful. And I'm guessing that you're thinking about quite a few of your applications and which materials might be best. So like I mentioned, we'd love to talk with you. Feel free to send me an email directly. My email's up there. It's kelsey@neometricstech.com, or feel free to give me a call. As you can see, my contact information's all there. So we are available to assist with any 3D printing services as well. So just send us CAD files, ideally an STL file of your projects. If you're looking for your own system, we'd really love to learn more about your specific needs, and I'd be happy to help pair you with the ideal 3D printing solution. And then finally, as a reminder, if you're in the Orlando area, please come visit us for our open house next month. You can see our 3D printers, as well as our 3D scanning solutions. It's always a fun time, so bring your parts and CAD files, and we'll be here with snacks. So thanks again for your time, and we hope to see you in person next month. And were there any questions? I did have a question. Somebody actually said, can you use more than one material at a time? And yes, so that's a great question. So some of these printers are actually dual extruders. And so that means you can print more than one material at a time. And often what people like to do is use a special support, maybe a one that dissolves. So as long as there's 2 extruders, you can. And somebody else had asked, are you limited to a material list? And again, it depends on the printer, but there are a couple of them that are open printers. And so when we said that they're open, then you can use materials from a third party. So that is an option. An advantage for any of the printers, if you use the materials by the manufacturer, the printers are already preset so that you don't have to worry about any of the temperatures. So it's always kind of an advantage to use the recommended materials. But like I said, if it's an open printer, then you do have the option. But yeah, it looks like we're coming up at the end of our time. So if there's any questions we didn't get to, we will be happy to email you, and definitely reach out to us. Thanks again, guys. Have a good weekend.